Now, for the general public, when they think of nuclear reactors, they immediately think, what can go wrong? And many people worried that a nuclear reactor, this chain reaction, could just run away and they could explode as an atom bomb. But that's actually not an issue. The reactors can't explode as nuclear bombs because the uranium they use is not enriched enough. It would need to be enriched at 70, 80, 90% to explode as a bomb, even if it was designed as a bomb, which they are not. So there's actually no chance of them exploding as an atomic bomb. But you could still get a more slowly running away reaction. And this is exactly what happened at Chernobyl in the former Soviet Union. A note on spelling: Chernobyl is what the Russians called it, Chornobyl is what the Ukrainians call it. Now in this case, we did get a runaway reaction. So an operator error made the reactor get too hot, and this meant that the water coolant started to boil. Now, in a typical pressurized water or boiling water reactor, the water is acting as the moderator, so if it boils, you get less moderation, which means the chain reaction will stop. But in this Russian design, that does not happen. It's what's called a positive void coefficient. That meant when the water went away, actually the reactor started working more strongly. This is because the moderation was caused by something different, by graphite rods, and the water was actually mopping up some of the neutrons. So it got hot, the water boiled, and that meant it got even hotter and the chain reaction went faster and faster. At this point, they tried to insert the control rods to slow it down and stop the reaction, but the control rods were designed with graphite at the bottom, which actually sped things up, and then the actual neutron absorber, when they tried to push it in, it got stuck. It got stuck at the point where they were actually speeding things up rather than slowing things down. So the reaction just went out of control, got stronger and stronger and stronger, everything got hotter and hotter and hotter. And there was no containment vessel. Again, Western reactors are encapsulated within multiple layers of thick concrete, so those things do go wrong. Hopefully most of the radioactive material just stays on the site, but they didn't have these in the Russian reactors. And so large amounts of radioactive waste, as we'll see later, escaped and contaminated huge areas. So that's kind of the worst case scenario. The more common type of failure, which has happened twice, is what's called a meltdown or cooling loss. The first case is a 3 Mile Island reactor in the US, but it also happened in Fukushima in Japan. In this situation, the cooling failed. So remember, you need to have water, steam, whatever it is, flowing through to take the heat away and drive it to the power plant. 3 Mile Island, again due to a stuck valve and some operator error, the cooling system failed. And at this point, the water started boiling and that shut down the nuclear chain reaction. Same thing happened in Fukushima. Once again, there was in this case a major tsunami and the reaction shut down. So the nuclear chain reaction shut down in both these cases. Unfortunately, stopping the chain reaction is not enough. The reason is that when you shut down the chain reaction, that cuts down 97% of the power output, but you're still getting 3% of the power output because you've got lots of radioactive elements left over from the reaction inside your rods. And 3% of the full power output is a lot better than the full power output, which is what blew up at Chernobyl, but it's still enough to cause a lot of trouble. And this 3% won't go away quickly. It only go away as these radioactive elements decay over their half-lives. So it's going to stay hot for weeks or months, even after you shut down the reactor. So at 3 Mile Island and Fukushima, the cooling was shut down. At 3 Mile Island, again, due to technical failures and operator error. At Fukushima, they cooled it for a short while after the earthquake struck, but then a tsunami came down and flooded, it knocked out the power supply to the cooling. So in these points, things get very hot. Nothing like as hot as Chernobyl, because you don't have an ongoing chain reaction, but still hot enough that it can melt the fuel and melt the steel around it, let the hot water and the steam get out. When the hot water and the very hot metals contact some of the fuel rods, you often get hydrogen gas produced. At 3 Mile Island, that hydrogen gas was vented, but at Fukushima it exploded. And so some radioactive gas escaped. You get the actual meltdown because you've now got a blob of all the different things that made up the reactor core, which have now melted, and they will fall to the bottom of the containment and start melting their way through it. And this is hence the name meltdown. It's not normally clear what exactly happens because you don't want to come close to look. But at 3 Mile Island, it looked like it melted part of the way through the concrete. At Fukushima, it probably went all the way through the concrete. Now, in both cases, there were actually no deaths. Some radioactive gas escaped, but not enough to kill anybody, unlike Chernobyl. But it was still very nasty, and lots of nuclear reactions going on and radioactive material being vented. So you don't want this to happen. There's currently a lot of concern about the Zaporizhia nuclear reactor, which is in Ukraine, which is caught up in the Ukraine war. It's more or less on the front line between Russia and Ukraine on the side of the lake. It's currently controlled by the Russians. At the time of filming this, it had been entirely shut down, so there are no chain reactions, but you're still getting that 3% heat, which means you still need enough power to drive the cooling even though the reactor's shut down. And so the question is, what happens if the power supply goes out? And a lot of people are thinking about what to do about this. The longer it stays shut down, the half-life means the radioactivity will decrease. So it probably would look more like a 3 Mile Island or Fukushima disaster rather than Chernobyl. But of course it's a war zone. What happens if someone deliberately or accidentally drops bombs on it or crashes planes into it or something like that? Maybe that could cause some radioactive release. So people are worried about that at the moment.